This is responsive architecture, or I'm tempted to keep with the one-word topic and call it responsivity. But then I hate the way that sounds, so I'm back at responsive architecture. And this is, of course, the first term in the title of the course, and this is the one that is probably nearest and dearest to your aspirations in terms of taking this course. And it's also the specific topic that several of you have selected for your term project. So in a way, this is an important moment of truth for the course to really test to see if this idea of reflexivity can have a meaningful role in the near future of our discipline of architecture. Of course, it starts in this thing called parametricism. How many people have heard the term parametricism? Patrick Schumacher, one of the principals at Zaha Hadid's office, has planted his banner in a fairly sloppy way, claiming that modernism is over. Now it's parametricism, demonstrating with great clarity the fundamental self-destructive instinct of architectural culture. We must kill the last thing in order to do anything new. It's basically a reproduction of what capitalism does. Capitalism operates and thrives on planned obsolescence. It's embarrassing to have last year's car model, so you buy this year's car model. We do the same thing in architecture. In order to do something new, we have to kill what came before. And that is one of the fundamental characteristics of the modern movement, which we saw in the last reading on cybernetics, with Walter Gropius declaring the study of history to no longer be a valid activity at the Harvard School of Design. He got rid of the history courses and the library and said, you can't study history. We have to kill everything that came before, which of course is one of the least reflexive things you can do, is to eliminate the possibility of learning from the past. Parametricism, if it weren't so fixated on killing everything that came before, well, as long as we don't drink the Kool-Aid that Schumacher is serving up, we should realize that these forms are very familiar to us from a more decorative, handcrafted past. If you look at the mosaic tile patterns of Muslim architecture, or the designs on the facades of Louis Sullivan's buildings in Chicago, or Baroque or Rococo, you'll see things like this that used to only be possible through handcrafted building production. We eliminated that in the name of industrial mass production, and now here we are back. So in a way, there are several significant threads that reaches back from the parametric endeavor back into history. It's a reconnecting of history, not a rupture in history. Make sure you don't fall into the trap of the planned obsolescence of architectural culture. Parametricism is facilitated by Grasshopper. How many people have tried this? It's a very interesting place to go with architecture, and it's quite elegant in the way the object-oriented software works. I recommend it highly to see if you can get it to do something. Here's some of Mr. Schumacher's work with Zaha Hadid. The creation of forms where there is a minimum of repetition. Things shift and change constantly. There's no modularity here in terms of mass production that you can assemble. It's not a Lego kit, it's the anti-Lego kit. And one of the most exciting things that I've seen coming out of this is Zaha Hadid's proposal for Istanbul, where finally the freeway forms of her shapes actually make sense because it's for the shape of urban freeways. It actually starts to form very interesting islands of sheltered spaces again, sheltered against the flows of traffic that is characteristic of 21st century cities for the time being. So the challenge of parametricism is, and I wrote this in the course description, is it cool? Yes. But is it useful? Maybe. Maybe it's useful. It's certainly useful if you want a great cheese. But is it useful for other things? Let's say you want to, I don't know, keep the sun from, let's say you live in the desert and you want to keep the sun out of your windows. Does the pattern of sunlight change as you move around a building? Yes, it does. So shouldn't the pattern of the form of the building also change? So this is should not be as much of a leap, conceptual leap as it seems to be for those who are experimenting with parametricism. It shouldn't just be, wow. It should be, wow, that really helps solve this problem in a new way that was not available to us previously. So you will recall in the original reading for the course, the author is asking the question, parametricism, sure, but what parameters? What parameters are you testing for? Is it, are you testing for the sex appeal of a form? Does it like say, wow, cool, I'll never forget that form? Or does it test for the solving of specific problems of which there is no shortage of? So what problems are these things supposed to solve for? And so we move now from static parametricism into things that move and change. And things that move and change in response to human engagements. And so we get Mei-Jin Yoon's, an architect here in town, Mei-Jin Yoon and her partner Eric Holler, who has been to Wentworth quite a few times. What's the name of their firm? Howler and Yoon, right? And they came up with this white noise, white light field of interactive poles with lights on them that is an early experiment, early as in 8 years ago, in Athens, Greece. They set up this field, and as you can see in these clips, that people move through this field, and there is a physical response. Not just that the poles with lights on them are moving from side to side, but as you will see in the next clip, the poles also are activated by human presence. That until they sense the presence of humans, they remain unlit. Oh, I was supposed to edit that out. But as you can see, as humans move through this field, the field of poles responds to the human presence. So the human body is the key factor. This is not just a static architecture, and it's not just a dynamic architecture. It is an architecture that is activated by human presence. And so this, so far, is it solving problems? Not yet. But it is tantalizingly provocative, and it should provoke us to consider what are the possibilities of this architecture? What could it do in terms of solving real problems? Similarly, we get increasingly the internet is filling up with these projects. They're often master's thesis projects where designers come up with these movable thingies, and they film it, put it on the internet, and call it responsive architecture. I'm not sure in this case what it's responding to. It might just be randomly changing because of the heat of its own mechanisms. Or it might be responding to sensors that are saying, humans are present, so now move. this has been taken around the same time. It was taken to, in a way, this is an extreme point of reference. Mark Goldthorpe, also here in town, over at MIT, came up with this hypersurface, he calls it, and there always seems to be a bizarre use of language associated with these things. But basically, it's a wall that is actuated by pistons that moves. And let me see here. I'm losing control of the machine. Okay. Do we see this one yet? This is Second Life. And the things that are very difficult for architecture students to do, even with a lot of time and motivation in the context of a master's thesis, there's the physical friction of actual material mechanisms in reality, and architects are not good with soldering irons typically. So it's much easier to test out some of these ideas in Second Life. And so here we have a responsive architecture, a speculation of responsive architecture. What if we could actually physically create systems where our environment responds to our human presence? Would we want to? The question I propose is, if we could do this, would we? It's kind of like the question, if we could fly, if there was no gravity and if we could float, would we like that? Would that be a good thing? And the more I think about that, the more I realize I love gravity. It's so great to be stuck under the surface of a planet. It's very convenient. All your friends are there. All your stuff is there. If you drop something, you know where it goes. It's extremely convenient. Similarly, when we got rid of the horizontal gravity of cities, when we invented the automobile and spread it out and put it in everybody's hands, we lost the horizontal gravity that used to hold us together in cities. And a lot of people think that was a mistake. And if you ask the planet would say, yeah, mistake. I'm dying here. So if we could do this, similarly, in a similar spirit, if we could do this, would we? I'm not so sure. In a way, that's a challenge for your generation. If you could do this, and it's increasingly apparent that maybe we can, things are changing every week. There's a new YouTube video about self-replicating structures. They're not organisms, but they are chemicals that are self-ordering, and you can actually get them to build structures on their own. MIT, they've got a robot that's like a spider, and it can weave a house. It can weave a structure on its own cybernetically. It responds to the places where it can connect to, and depending on the geometry of the site that it finds, it will generate a different form of a structure depending on what it finds there. It's on, look up MIT Media Lab, robot weaves its own house, something like that. So the challenge with this stuff is, why do this? So far, and this is a common problem, especially in this part of the world. Boston is filled with computer scientists. Wentworth has a very sophisticated computer science department. Every summer, their seniors are producing these remarkable projects, and it's something like this. They can do these incredibly powerful things, and you ask them, well, why would anyone want to do that? And they kind of stop and they say, I don't know. They have no idea what to do with these possible mechanisms, and it might be that architects need to help out. Looks like we jumped here. So we did that. We did this. And so the reading for Tuesday is by this very sharp guy who's probably too smart for his own good because he keeps coming up with these very strange ways of talking and expressing himself. But this is his thing. He created this Hylozoic soil, and I'm sure he will explain what that means. But it's basically, there is no living organism behind this, but there seems to be. And so he created this for the 2010 Venice Biennale. It's already ancient history, 2 years ago. But people walk into this space, and this hanging thingy, again it's a thingy, starts to twitch and move. Can you see it? No one's pulling strings. This is an autonomous response of this hanging thingy. He calls it architecture. He even goes so far as to call it potentially a new ground plane. So you turn the camera upside down and you picture this as a ground condition. He calls it a geotextile, which is a common technology for stabilizing soil. And so what if you stabilized the soil with this kind of a geotextile, and when you went jogging through the park, it twitched as you went by? Sure, we can do that, but why would we do that? So this is a classic problem of architects and architecture. In a way, this is brand new. It's a whole new ballgame, people. But at the same time, it's the same old, a lot like the discussion we just had. Technology allows us to do new things. And it falls to us to figure out what to do with it. If we continue doing what we have been doing, it all becomes just a parlor game. It's just, a bunch of architects producing entertainments for other architects. But in the meantime, there's a whole world out there of people needing our help. The question is, are we ready and willing and able to offer our help, or are we satisfied simply to create entertaining objects for our own amusement? And so far, it's mostly amusements. But when you hear this guy talk, he's very convincing about the fact that he is committed to identifying the pragmatic possibilities of this to solve real problems. And that's what suddenly shifts it for many of us and makes this a very serious endeavor. This is not just a bunch of artists entertaining each other. This is asking the tough questions about what is possible, what does this imply, what are the responsibilities that face designers when faced with these new powerful trends. And if you haven't, how many people have looked at the resources part of Blackboard? I really encourage you to do that, and I'd like to think that you guys are actually able to add things to that. I'm not sure if that's true. If you find something on the internet that you think would be useful for the discussions in this class, please attempt to add it to the resources tab. And if you can't do that, send me an email. But I already have a list of about 100 things that are not up there yet. Alternatively, we could also grant you some type of instructor status so you could populate things on there. But the internet is filled with information about self-replicating structures, carbon digesting paints and organisms that you just paint the outside of the building, and it will actually remove carbon from the atmosphere. So some of these things are starting to look like they hold some promise for solving real problems, and not a moment too soon. Okay, I'm going to stop there. Thank you for staying a little longer.